Hello, and welcome to this segment on design verification and validation, or V&V. Broadly speaking, this covers design evaluation for when we're looking beyond the conceptual design level. Basically, we're looking at determining to what extent our design is successful. And this requires going at least to detailed design and typically to some sort of prototyping. Design verification looks at how well our design satisfies the technical design requirements that we had established back in the requirements phase. So when we're comparing whatever we've created against our requirements here, we're usually more concerned with our requirements that were not specific to any particular solution. So we're not talking about that refinement of requirements that takes place as part of the process of going to detailed design. Those additional specifications that get fleshed out as you're going from concept design to detailed design. That's not really what we're focused on here, although sometimes that is part of it. Usually our main focus is on those non-solution specific requirements that we did back before ideation. Design validation looks at how well our design actually meets the needs of our user or client, how well it serves its intended purpose. Precise definitions vary for both of these terms, and the line can blur at times, but that core distinction is important. There are also some other usages and meanings of the terms verification and validation that I'm not getting into here. So let's consider some basic examples to get a sense of the distinction. Say we're measuring the weight of our product to see if we're under a limit that we had set for ourselves. That's design verification. But suppose that weight limit was part of how we had translated a customer need for portability. Now then, what if we met our weight limit, but it's still too heavy for our users to comfortably carry for however long or far they needed to? That gets into design validation. Similarly, what if the weight is fine for our users, but the product is too large or cumbersome to carry, and we simply didn't even have a design requirement that addressed that aspect of portability? Design validation, therefore, in essence, looks all the way back to the client or stakeholder's actual needs upon which we based our technical requirements that we set. This means that validation in effect reflects whether we had set our design requirements correctly and adequately. As another example, if we test the operation of a machine that we designed to see if it runs without problems or errors, that falls under verification. However, having prospective users test it to see whether it actually does what they want and works how they want would fall under validation. A common shorthand way of thinking about the distinction is verification asks, did you make it right? And validation asks, did you make the right thing? So design verification is going to be more objective than design validation, because with verification, you're comparing what you came up with against your requirements specifications, as well as any requirements that you were not able to develop into a specification, but were still able to develop somewhat beyond the raw information you got from stakeholders. The key thing to realize at this point is that we cannot simply assume that we correctly understood and translated all of the user needs, all the needs of our stakeholders that got reflected in design requirements. As much as we try our best to do that and to make sure we capture and translate all the stakeholder needs that need to be reflected in our technical requirements, sometimes we miss something or we don't get it right, and that's where validation comes in. This is why verification isn't enough. That only tells us how well we've met the technical requirements that we set for ourselves. But as far as our clients or users or other stakeholders are concerned, what they really care about is whether the end product actually does what they want. This goes to why, when establishing our design requirements, as we discussed back then, it doesn't really pay to specify things with any more objectivity than we can truly justify. Because in the end, any forced or artificial objectivity helps us only with verification. And that benefit is illusory, because over-quantification or under-supported precision will get exposed during validation. So we may as well be honest with ourselves about that throughout the process. At the same time, the more objectively we can legitimately make our requirements, the narrower the gap we'll have between verification and validation. So again, we want those requirements to be as specific and concrete and as objective and as quantitative as possible, but we don't want to force it. Okay, now, so having established those concepts, what are some ways that we can actually perform verification and validation? Well, for verification, sometimes aspects of it can be done without physical testing, even for a physical product. For example, certain dimensions from detailed design specifications might be able to establish whether certain design requirements were met. Also, things like structural integrity or heat generation might be determined to some extent by calculation or simulation. Remember that virtual prototyping can facilitate often faster feedback loops that tell you at least something about your design's viability. Although sometimes physical testing is indeed necessary, and this can be anything from inspection for certain dimensions or other observable aspects to more involved or extensive interaction. In any case, during verification, you should always be referring back to the technical requirements that you established. Now, for any requirements specifications in those requirements, you should plan for tests that would indicate whether you've satisfied any hard limits, such as a minimum speed, a maximum width, etc., and also try to measure how well you've fared on any directional requirements, like things you want to maximize or minimize or target. Design validation generally requires actual testing of an actual embodiment of your design, whether or not verification did. And here, the testing should be in the actual environment and circumstances of use to the extent possible. Of course, depending on what sort of prototype you made for a given iteration, this will be more feasible in some cases than others. For example, a test bed or a focused test bed prototype may not be well suited for all the tests that would ultimately be needed to evaluate your solution against all your requirements. That's okay. Learn what you can, and then see how far back you need to go in a given iteration. Also, note that some requirements may need to be tested in a more subjective manner, such as with psychometric evaluation or rating scales. In planning any test, you need to identify what your objective is for that test, which should involve always yielding some kind of information relevant to one or more of your design requirements. Then think of what steps would produce results that provide that information to help inform subsequent iterations. In many cases, the results of a given test that you come up with may vary each time that you do it. Sometimes this variation won't make much of a difference in whether a requirement was met or not, either because the variation was so slight from one repetition to the next, or because the range of variation is clearly inside or outside of what you deem acceptable. However, there are times when the uncertainty of results must be quantified and understood as well as possible. This can be part of how we avoid over-engineering or under-engineering for certain requirements. That gets into some statistical considerations, such as design of experiments, that we're not getting into at this level, but you should be aware that those often will need to be taken into account. Okay, that's it for this segment. Thanks for watching.